In today's lab, we're going to do an experiment with lenses, and specifically we'll be using a converging lens. So for a converging lens, there's a focal point on either side of the lens, and if light approaches the lens from infinity, it's going to come in with parallel light rays, it will pass through the lens and then converge to the focal point on the opposite side of the lens. Likewise, if the light starts at the focal point, it will spread out, pass through the lens, and then emerge in parallel light rays, which forms an image at infinity, and really that just means it doesn't form an image at all. Now we also have the focal length, which is the length or distance between the lens and either one of those focal points. For objects not located at infinity or at the focal point, we can use the thin lens equation to relate the image and the object distances. So the equation says that 1 over the focal length is equal to 1 over the object distance, s, plus 1 over the image distance, s prime. The other equation we need for this experiment is for lateral magnification. So magnification, that's relating the image and the object size, and the magnification m is equal to the image height divided by the object height. And it's also equal to the negative of the image distance divided by the object distance. So there are 3 things we need to do for this experiment. First, we need to measure the focal length of our lens. Second, we'll be testing the thin lens equation by measuring different image and object distances. And then last, we'll be measuring the magnification at a set distance. The first thing we need to make for our setup is something to hold the lens in place so we can set it down on the table and then it will stand upright and we can use it hands-free. So this is an example of the lens holder that we'll be making. I made this one previously, but I'm still going to walk through the steps and show you how we can make something like this. To make this, we're going to use some aluminum foil and modeling clay. We'll be starting with the clay. So just squish this down until you have a long rectangle, something like this. And then we're going to squish it down in the center and draw it up on the sides to make a U shape, just like I did for this one. So now I've got something like this one, but I need to check and make sure that it's the right size for the lens. When you handle the lens, make sure that you take this out carefully and don't touch the flat surfaces of it. Make sure to grab it from the edges, just like this. Otherwise you'll get smudges and stuff on the surface of the lens and it won't make the image as clear. Now compare the lens to the clay and see if the clay is about the right size. And in my case, it looks like it is, so I'm going to set the lens to the side. And now we need to cover the clay in the aluminum foil. Now the clay is covered by the foil, and this serves 2 purposes. 1, it protects the lens from the clay residue, and 2, it makes it just a little easier to form it to the shape of the lens. And later we'll go ahead and trim off this extra foil, but for now I'm just going to leave it there. Now just take the lens and carefully squish it down into that U-shaped trough of the clay and the foil. And this will sort of dent the shape of the lens into the clay and the foil and make it have a groove in there that will allow us to hold the lens in place. Then just squish the clay and the foil in around the base of the lens, and make sure when you do this that the lens is straight up and down. You don't want it at an angle or something, so make sure that it's straight up and down, and then just press the clay and the foil in to make a nice deep groove, and you can keep pressing the lens down as well while you're doing that. So when you get done, it should have a groove that goes around the edge of the lens and will hold it in place for the experiment. So that looks pretty good, and now if I were to remove the lens, you can see that we've got a nice deep groove that goes through the middle there. And I'm just going to set the lens to the side for the moment so you can see this a little bit better. So we've got this groove that goes right through the middle like that, and that makes it really easy to just set the lens right in there, and it holds it in place for the experiment. Now because I've got all this extra foil around the outside, I'm just going to use some scissors and trim it off. Also make sure to leave the clay exposed on the bottom, and this will make it just a little bit sticky so that it doesn't slide too easy or tip over. And that's it for the lens holder. One last step for the lens holder that I forgot to mention is we need to draw a line down the side of it using a Sharpie or some other marker just to mark out the edge of the lens, and this will make it easier to measure the distances later. Next, we need to make a screen to project our images on, and we're going to do that with the wood block from the first semester labs, an index card, and some Scotch tape. All you need to do is take the index card and tape it to the wood block, and we need the lined side facing toward the wood so that the blank side is facing out. And then also lift it up just a little bit so that we've got a gap here at the bottom. If you have it all the way down, then see it doesn't slide very well. So lift it up just a little bit, and then we'll tape it down here at the bottom, and then also at the back. The last thing we need to make is the object, and normally this would be some sort of transparent slide with a picture on it that you can shine light through and then project an image of it on the screen. However, instead we're going to be using some paper, and then we'll cut a hole out of that paper, shine the light through the hole, and project an image of that hole on the screen. So in this case then, the hole is our object. And this is an example of one that I've made previously, but I'll show you how we can make it again using any sort of thick paper that you might have on hand. I'm going to use some black cardstock paper for this, but you can use any sort of thick paper that you have on hand. If you have leftover conductive paper from the earlier labs, that should work fine, or if you want to use cardboard, maybe some cereal box material or something like that. It just needs to be thick enough that when you bend it a little bit, then it can stand up on its own on a flat surface. Let's start by cutting out a square of the paper, and it doesn't have to be an exact size, but I think I'll do about the same size as I did before, which is about 10 to 12 centimeters on each side. So I just want to cut that out, and then we'll fold it in half. It looks like in my case it didn't quite fold properly, so I'm just going to trim off the extra paper here so that it can stand up straight. And let me just check. That stands up pretty good. We're not going to want to fold it quite that much though, so let me just unfold it a little bit. That looks pretty good. It's maybe not quite as flat as I'd like, so I'm just going to trim it a little bit more so that it stands up easily and doesn't tip over. Alright, that's pretty good. I'm going to let it go with that. Then we need to cut a hole near the bottom of our paper. And you can see what I did here where I cut out half of an arrow, and it doesn't need to be some sort of directional shape. It could be an arrow or a triangle or something like that, because the image formed by a converging lens is going to be flipped upside down. So with this, I have an arrow pointing up, and then the image would be an arrow pointing down. So the idea here is to place our hole at roughly the same height as the center of our lens. And if I overlap these, you can see what I mean. We've got the hole roughly in the center of the lens. It's not exactly, but it's pretty close. And it needs to be about 2 centimeters tall. So about 2 centimeters tall, and then shift it up enough so that it lines up with the center of the lens. And now we can just check and make sure that it's at the right height for our lens. So if I line that up just like that, that looks pretty good. I think that will work just fine. Now we need to measure the focal length of our lens. And for this part and the rest of the experiment, we'll need to shut off the lights in the room, or at least most of them, so that we can easily see the images projected on our screen. The focal length of my lens is supposed to be 15 centimeters. On the box it says 150 millimeters, which is 15 centimeters. So if your focal length is printed on your box, that's great. It gives you a starting point. But this is an experiment, so you will still need to measure it directly, which is what we're going to do now. To test this, we need a lamp or a large flashlight of some sort. Your phone flashlight is probably too small, but you could also use a window. If you have a window across the room, you could use that and then focus on something outside the room. Ideally, the light source should be infinitely far away, but for this experiment, just place it at least 5 or 6 meters away from your lens and your screen. For this, I'm going to use my desk lamp. You can see it's got a very distinctly shaped bulb, so I'm going to place that all the way across the room, 5 or 6 meters away, and then shine it back over here and project an image of that light bulb on my screen. Alright, most of my lights are off now, and I've got the desk lamp across the room over there, 5 or 6 meters in that direction. It's aiming back over here, through the lens, and at the screen. So what we do is place the screen, the lens, and the light source all in a row, and then just adjust the position of the screen until we achieve a sharp focused image of the light source. So we just adjust it here, and it looks like right about there it's focused. So we can check, here it's out of focus, here it's out of focus, and in between we can achieve a nice sharp focused image of that light bulb. So it looks like maybe about right here is the most focused. And then we can measure the distance with our ruler. So I'm going to line that up here with the 0 centimeter end on the screen, and then the other end at the edge of the lens. So this is where that line that we drew comes in handy. Just line that up, and it looks like it is pretty much at 15 centimeters, and that's what we expected. It's a 15 centimeter focal length, and I have now confirmed that experimentally. Now we're going to test the thin lens equation, and to do that we're going to set up our lamp, our object, our lens, and the screen all in a row just like I have here. And then we'll measure the distance between the object and the lens. That will be our object distance. And then between the lens and the screen, which will be our image distance. And when you set this up, make sure to use a firm, flat surface. If it's not flat, then the object, the lens, and the screen may not be in a straight line. They may be on a curved line or a slant or something that may not work as well, and so the image may not form properly on the screen. Also, with the object, make sure to unfold it as much as you can. If you have it bent too far, then the front of the hole and the back of the hole won't be in focus at the same time, which will make it harder later. And also, if it keeps falling over, then you could add some tape just to stabilize it. First, we need to set the object distance, and we're actually going to leave the object in place. We're not going to move that, but we'll measure everything else relative to that. So line up the tape measure so that the end of it is lined up with the hole. That looks good. And then the first object distance is going to be the focal length plus 5 centimeters. So in my case, I had a focal length of 15 centimeters, so our first object distance is going to be 20 centimeters. I've set the lens now at 20 centimeters, and this is 20 centimeters away from the hole, so that's our object distance. And then we just need to adjust our screen until we form a sharp image. So it looks like it's focused right around here. Let's just check. So here it's out of focus. Here it's out of focus. So we just need to split the difference and find the spot in the middle where it is the most focused. So it looks like it's focused right around here. So I just need to set it right there, and then we can measure the distance. Now, there's a couple ways you could measure the image distance. The way I'm going to do it is by leaving the tape measure in place. Right now, the screen is at 68.5 centimeters, but that's relative to the object. The image distance is from the lens to the screen, so I just need to subtract off the position where the lens is at. So the lens is at 20 centimeters, so I just have to take 68.5 centimeters minus 20 centimeters, and that gives me an image distance of 48.5 centimeters. For the next measurement, we're going to increase the object distance by 5 centimeters. So right now it's at 20 centimeters, and I need to move it to 25 centimeters. Then again, I need to adjust the position of the screen until I achieve a sharp focus. So it looks like right around here. And again, let's just check. Here it's out of focus. Here it's out of focus. So in between, looks like around here. And this one is now at 57.5 centimeters. So the screen is at 57.5 centimeters, the lens is at 25 centimeters, and then the image distance is going to be the difference of those two. So 57.5 minus 25 would be 32.5 centimeters. So I had an object distance of 25 centimeters and an image distance of 32.5 centimeters. So we're going to continue this process of increasing the object distance by 5 centimeters each time. First of all, we had it at 20 centimeters, which was my focal length of 15 plus 5 centimeters. So we had focal length plus 5. Then we did 25, which was focal length plus 10. And then we'll do focal length plus 15, plus 20, plus 25, and plus 30. So that will take me all the way up to 45 centimeters, but depending on your initial focal length, then that final number and all the numbers in between may be shifted somewhat one way or the other. So I'm just going to skim through the rest of this process. We're going to go up to 30 centimeters. So I'm just going to place that there and then adjust this. So now I have my image distance right there. So object distance and image distance. Then I'm going to go up to 35, adjust the screen until I achieve a sharp focus. Then we go to 40 centimeters. Again, adjust the screen. And then the last one will be at 45 centimeters. So I'll just line that one up right there and then shift it until the screen is in focus. So that gives me my object distance and image distance. And again, like I said, if your focal length is different than mine, then you might not go up to 45 centimeters object distance. You might go up to 50 centimeters or some other number depending on your focal length. But either way, you should end up with 6 sets of measurements. The last thing we're going to do is test the lateral magnification equation, and we're going to do that by setting the object distance to 40 centimeters. So I just need to adjust my lens to 40 centimeters, and then as before, I'm going to adjust the screen until we achieve a sharp focus. So here it's out of focus, here it's out of focus, and then we just shift it forward until we again have a sharp focus. So it looks like right around here, and I'm just going to shift that over so we can see where it lines up. Looks like this is at 62 centimeters and the lens is at 40 centimeters, which means I have an object distance of 40 centimeters and an image distance of 22 centimeters. Then the other thing I need to measure is the image height and the object height. And I'm going to start with the image because if I move the object, then that will change the image and then I won't be able to measure that. So I'm going to start with this and then we can measure the object after that. To measure the image height, I'm just going to place the ruler right here next to the arrow and then just measure the height of that arrow. In fact, if I move it back just a little bit, I can actually get the image to focus on the ruler and then measure it that way. And it looks like the image height is 1.5 centimeters. Then to measure the object height, I'll just set it down here on the table and measure it with the ruler. Just to note, the magnification should come out negative, and that's because the image is flipped upside down. In the case of the object and image distance, s and s prime, you could just use the positive values that we measured for that because the negative is built into the formula. But for the image height, you need to use the negative of that value because the image is flipped upside down. So you'd have a negative image height divided by a positive object height, and then together that makes a negative magnification. And that's it. So just read your instructions carefully. They will have more information than what is shared in the video, and good luck on your experiment.